Hey, Calculus kids, this is Dr. Callahan with week 16 Wednesday. How are you guys doing? Here are the following 3 questions for you guys for your warm-up blog. I think questions 1 was more, I guess, aimed for my freshmen because, they're a little bit more rambunctious. But you guys are all smarty pantses, and I'm sure you guys will do just fine. Your behavior probably wouldn't change, between high school or college because you guys are just awesome. All right, so today we're going to talk about a free response question that is in the no calculator portion of the 2010 free response for question number 4. So we're going to go ahead and take a look at this. I'm going to give you guys a minute to kind of get yourself acquainted with it. And here it says the graph of the function f shown above consists of a semicircle in 3 line segments. Let g be the function given by g of x. And so notice that this is just a function of f, it's not f prime. So as you're interpreting the graph, it might be a little bit different than it is with f prime. And so A basically asks you to figure out, oh, I'm sorry. Yeah, we're on this one. I'm not quite sure why I had you guys go to that one. No, just skip, I'm sorry, skip that one. Sorry, we're over this one. A squirrel starts at building A at time equals 0 and travels along a straight horizontal wire connected to building B for 0 to 18 time. The squirrel velocity is modeled by the piecewise linear function defined by the graph above. So in this situation, because this is a graph of velocity, it is the first derivative of the position function. So in case this one is actually modeled as a derivative, the first derivative anyways. So just keep that in mind as you're interpreting the graph itself. So if any, does a squirrel change directions between 0 to 18? 0 is here, 18 is here. Given the fact that this is like from the derivative, remember everything above the x-axis is going to be a positive slope. Anything below the x-axis is a negative slope. And keep in mind that when x is going to be, or excuse me, when y is at 0, this is where your max and min is going to be because the critical point is at 0. These are your critical points, 0, 9, 15. All right, so as I'm looking at this for question A, I can say that, just like I said before, you're looking at the points, the critical points. Critical points is when your slope changes from positive to negative or negative to positive. And you can tell because everything over here between 0 to 9 is a positive slope. But then it changes direction from 9 to 15, which becomes a negative slope. And then it changes again from 15 over to 18, which then becomes positive again. So when I ask you about the directions of the squirrel, you can say that the squirrel changes directions when positive to negative at t equals 9 and changes directions when it is negative to positive at t equals 15. Because the velocity changes signs at those times. And that's something that you can go ahead and write. And when it says give a reason for your answer, this is sufficient reason. So if you have that, it is just 2 points, 1 for the t value, so your time is at 9 and 15, and then 1 for the explanation. So that's pretty simple for the most part. Now let's go ahead and take a look at part B. Part B says, what time is interval 0 to 18 is the squirrel furthest away from building A? How far from building A is the squirrel at that time? Okay, so let's look at the critical points. 0, 9, 15, and then at the very end, 18. Okay, so 0, 9, 15, and 18. That's when the direction of that's the direction when, or that's the time frame when the slope actually does change. So what we can do here is we can look at something here, and looking at the areas of these shapes here. The first one is obviously a trapezoid. So with the area of a trapezoid, you are looking at 1/2 base height 1 plus height 2. So looking at this piece right here, your height 1 is going to be between 2 to 7, so that's 5. Plus height 2 is between 0 to 9, so that's 9. Your base is going to be from 0 to 20, so that's 20. 1/2 of that. So we're going to have 1/2 of 20, which is 10, times 14, so that's 140. So the area of this shape here is 140. Then let's take a look at the trapezoid on the bottom. You're going to do trapezoid as well. For this one, remember it's 1/2 base. Oh, you know, I totally wrote this incorrectly. Sorry. I realized that I got this mixed with the trapezoid and some. It's base 1, base 2, height. Numbers doesn't change. It's just the way you perceive them. So the height of this is from 0 to 10. So that's 10. And then base 1 is from 10 to 14. So that's 4. Plus base 2 is going to be from 9 until 15. 2, 3, 4, 5, 6. So that's 6. And so looking at this here, you have 1/2 of 10, which is 5, times 10, which is going to give you a negative 50 because it's below the x-axis. And then lastly, you have this piece right here. That's also a trapezoid. So I'm going to put trapezoid 3, area trapezoid 2, area trapezoid 1. Oops. And that's going to be 1/2 base. So your height. Your height is going to be from 0 to 10. Base 1 is from 16 to 18, so that's a 2. Plus base 2 is from 15 to 18, so that's 1, 2, 3. 1/2 of 10 is going to give me a 5 times 5, which is going to give me a positive 25. So now that you have the area of those shapes, you can say something to the effect of the distance from A are 140 at t equals 9. And then it is going to be at t equals 15. So from 0 to 15, it's 140 minus 50. So that's 90 at t equals 15. And then at t equals 18, it's going to be 140 minus a 50 plus a 25, which is going to give you 115 at t equals 18. And when it is t equals 0, the area is 0. So looking at the maximum distance, 140 feet at 9, 90 at t equals 15, 115 at t equals 18, 0 at t equals 0. So which one has the furthest distance? And sometimes it's easy to become complacent with what the question's asking you. So how far from the building A is the squirrel at this time? The furthest away from squirrel B. So you could say the squirrel is farthest from building A when t is equal to 18 at 115. Oh, I'm sorry. 140 when t is at 9. There we go. And so that's your answer for B. So looking at B right here, it is going to be worth 2 points. One for identifying the candidates, and the candidates are the 4 times at 0, 9, 15, and 18. 1 point for the answer, and it's at 140, t equals 9. Okay, so let's go ahead and take a look at question C. For question C, it says what, or find the total distance, which is going to involve, remember, absolute value. Squirrel travel during the time interval between 0 to 18. So then when I look at this right here, your distance traveled is going to be between the integral of 0 to 18, absolute value, v of t dt. And since it's an absolute value, the negative does not matter. Okay, remember this one was 140. This is a negative 50. This one was a 25. And it's just going to be 140 plus 50 plus 25, which is going to be 250, 15. And a good way of remembering this is like, remember when you're looking at the absolute value, for example, of 2 versus the absolute value of negative 2. Both of these results with the answer of a positive 2, because it's not asking you for the quantity of something, it's just asking you for the distance traveled. So if I'm standing right here, what's the difference traveled if I were to go from 0 to 2? Let's say it's 2 miles. How many is it going to be if I go from the left direction? It's still going to be 2 miles. It doesn't matter if I went to the right or left, if it's positive or negative, it's still going to be 2 because it's distance traveled. And that's why we go ahead and use absolute value for distance. So that was pretty easy. And if you guys go ahead and take a look at the breakdown for this, for D or C, it is just 1 point because essentially it's just one answer. Let's take a look at question D, okay? So for question D, it's asking you for, write the expression for the squirrel acceleration, velocity, distance, x of t, so this is the position function, x of t, from building A that are valid for the time between 7 and 10. So we know a few things. We know that there are a few things that we do know from the problem itself. We know that the critical points are as follows. So I know that my critical points, when it is v of, because this is a graph of v, a v of 9, the slope is at 0. So using that right there, I know I can find that x of 9, which is right here, is going to represent the area of this piece right here, which is going to be 140. So then with that information, I can go ahead and find A of t, which is just going to be the slope of velocity. So just keep that in mind, because remember, v prime, which is a slope of v of t, is equal to the acceleration. So A of t is going to be the slope of velocity. So the 2 points I'm going to use is v of t, or v of 10, minus v of 7. And I want to choose those points specifically over 10 minus 7. So let's take a look at the y values. So when x is 10, so here is 10 right here. What is my y value? My y value is going to be negative 10. We'll put negative 10 right here. Minus v of 7. So when x is 7, what is my y value? It's 20. Divided by 10 minus 7, which is just going to give me 3. So then A of t is equal to negative 30 over 3, which is negative 10. And we specifically picked those 2 points because it's between 7 and 10. So it makes sense to use those 2 points specifically. So then from there, we also have v of t, which is going to be equal to 0 minus 10 times t minus 9. If I go ahead and distribute this, it's just going to give me a negative 10t minus 9, or distributed negative 10t minus or plus 90. Okay. As v of t. So I already got my acceleration. I already got my v of t. Next, what I need to find is my x of t, okay? So my x of t, remember, is your position function. Your position function is going to be x prime of t equals v of t, or the integral of v of t is equal to x of t. So I'm going to do the integral of v of t, which in this case is negative 10t plus 90. And so let's go ahead and integrate this. So 1 plus 1 is a 2. So negative 10 divided by 2 is a negative 5t squared plus 90t plus c. Well, it would be great if I can figure out what c is so that way I can complete this. And I can't because I know that x of t over here at 9 is equal to 140. So I'm going to put 140 is equal to negative 5 times 9 squared plus 90 times 9 plus c. This piece right here is going to give me a negative 405. 90 times 9 is 810 plus c equals 140. So then if I go ahead and solve for c, I will have negative 265. So then here's my x of t. X of t is equal to, going back to the original equation right here, before I was finding c. I will have negative 5t squared plus 90t minus 265. And this right here is going to be your answer for x of t. Here is your answer for v of t. And here is your answer for acceleration, a of t. All right, so let's take a look at D. This is worth 4 points, and 1 point for acceleration, 1 point for velocity, which is not too difficult, but then 2 points for the position function, which is requires a lot more time to do. All right, guys, so after this, what I want you guys to do is take a look at the bottom right here. These are some of the answers from previous students of how they went about doing the questions here. And if you have any issues, I have a link here to a video that also explains this one more time to you guys. So to practice with this, I want you guys to kind of flip over to the other side of your paper. This is a question that's similar to the one that we went over, and this is from 2004, free response question. It's also without a calculator, and I also have a grading scale right here for it, in addition to the QR code for the video that goes over this question. And that's basically it. I hope you guys have a wonderful week, and as always, stay safe and healthy. Take care.